In this video, I'm going to multiply these two rational expressions, and I'm going to do so by first factoring all the polynomials and then canceling any common factors they may have. Now, I want my original problem and my final expression to be equivalent expressions, so I'm going to identify any x values that will make my final expression undefined. So whether or not those are from factors that cancel out along the way or from factors at the end. Okay, so the first thing I'm going to do again is just factor all of these polynomials. I notice that first of all, x cubed minus 27 is going to be a difference of cubes. So difference of cubes are going to be, well, the cubed root of that is x, the cubed root of that is 3, and it's difference, so minus. And the second part of that formula is the square of the first one plus the product of the two cubed roots and then plus the square of the last one. And so right below here it looks like I have a 3 for greatest common factor, and what I have left is 4 minus x. Okay, moving on. On the top here, it looks like I have another greatest common factor of 6, so I'm left with x minus 4. And on the bottom, it looks like I have a greatest common factor at least here, so it looks like a 3 and an x can come out of that expression. When I do that, I have x squared plus 3x plus 9. A couple of things here real quick. This difference of cubes, this quadratic that I get, typically is going to be an irreducible quadratic. And I notice I have the same thing down here, so I'm not going to try to factor this down anymore because I see that it's already here, so I can just cancel them out. Okay? So these irreducible quadratics will cancel out. And previously I said that we're going to look for any common factors that cancel and ensure that their values weren't going to cause the denominator to be 0 or cause the whole thing to blow up and be undefined. But an interesting thing about these irreducible quadratics is there's no real value of x that I can plug in that will make this 0 in the first place. So I do not have to take him into consideration here or at the end as far as getting values of x that will make my expression undefined. Okay, so irreducible quadratics cancel and they won't yield any zeros anyway, not real zeros from the x values. So, okay, let's go ahead and finish this up. So I have a 6 up here. It looks like I have a 3 down here. So the 6 and the 3 will go to a 2 and a 1. And I have an x minus 4 and a 4 minus x. So if I were to factor out a negative 1 from here, I know that this would end up being negative 4 plus x. Or in fact, I could rewrite this entire expression as negative 3 and then x minus 4, because the negative 1 and the positive 3 multiply to make a negative 3. And then when I switch the order of these terms, x minus 4. Which then is nice because the x minus 4 here and the x minus 4 here cancel out. So what am I left with? Well, it looks like I have this x minus 3 on top with a 2. And on the bottom, it looks like I have an x right there and a negative 3. So let's see what that looks like all together. So I'll put that 2 out front and an x minus 3. And on the bottom, it looks like I had a negative 3 with an x. Okay, so I don't like to keep my negatives in the denominator. I either want them out front or on top. So let's put it on top. So negative 2 with an x minus 3 all over 3x. One consideration you could make, since we need to multiply these together anyway, let's see what that looks like when we do it. Negative 2x plus 6 over 3x. I don't really like having my leading term be negative, so I'm going to switch the order of these two in order to hide that negative in the middle as a subtraction sign. Okay, so I have 6 minus 2x over 3x But I have a couple of values of x that probably need to be taken into consideration. Maybe not a couple, maybe one. I don't know. We'll see here. So what all canceled here? Well, I know that my x minus 4 is canceled, so I know that x can't be 4, because 4 minus 4 is 0. And that would cause a 0 to be in the denominator, which would make it undefined. So it can't be 4. I also canceled out this quadratic, but we already discussed that that's an irreducible quadratic, so it will not yield any values, any real values of x that would end up being 0. So the only one then was 4. Okay, and I have this 3x in the denominator, I know, so I know that x can't be 0, but he didn't get canceled out. He's still present, so I can still see that. So I only need to make this stipulation here for any values of x that got canceled out that maybe aren't present right here. So what I have here, my final answer, this final rational expression, and my original multiplication problem up here, these are going to be equivalent expressions.